want to start looking at a tool called Metasploit. We are going to use it extensively throughout the class, so I want to start with some of the basics of using Metasploit, so we will come back to it. It's easier just to get the syntax down now, so we don't have to keep coming back to it throughout the class. So let's start by taking a look at some of the source code. We're going to use the free open source edition of Metasploit. So let's go to user share Metasploit-framework in Kali. If we do an ls on this directory, we can see some of our Metasploit programs as well as our Metasploit modules. All of Metasploit is going to be in our modules. If we go into the modules directory, we can see different parts of Metasploit, the auxiliary modules, encoders, exploits, NOPs, payload, and post modules. We will see all of these, except we're actually not going to work with the NOPs, particularly in this class, but we will see examples of some of the other modules. At any point, if we work with a certain module and you want to see its source code, you can just come into this directory and go into the relevant folder and move down to the particular module. These are all written in the Ruby programming language, so you may not be familiar with Ruby. We will actually take a look at a simple example of writing a Metasploit module towards the end of the course when we do exploit development, but primarily we won't really need to know any Ruby or really any of the nitty-gritty of how these work. We'll be able to use the Metasploit framework as is, but again we will take a quick example of building our own module. So, for example, we can go into, say, exploits. That's always fun. All of our platforms, that is broken down by platform. Say, Windows. And how about SMB? And these are all our Windows SMB exploit modules, so quite a few of them there. The first example we're going to take a look at is many people's favorite, and unfortunately for the state of security, despite its age, one that comes up quite a lot on my pen tests even today. We're going to look at this MS08_067_NetAPI.RB. .RB is for Ruby. So again, this is written in the Ruby language. So we can take a look at it. And again, just to use the Metasploit framework, you don't need to know much Ruby or, well, any Ruby. But again, if you ever want to see what's really going on behind the scenes, you can look at the module code. This one may seem a little bit fancy, but again, we will take a look at how to build at least a simple example of one of these modules in this class. So let's actually pretend for a second that there is no Metasploit, that we have to do this without Metasploit or some other exploitation framework. There are others like Canvas or Core Impact. Metasploit is just one example of an exploitation toolkit, or they call it a framework. Let's pretend they don't exist, and we are tasked with exploiting this MS08067 vulnerability that we have found on our pen test. Naturally, your question might be, how do you know that that vulnerability is there in our environment? And that's a very good question, and one that we will answer extensively throughout the course. But for now, for this one particular vulnerability, you can just believe me that it's there, so we can learn how to use Metasploit. There are several other vulnerabilities present, so you will have plenty of chances to discover vulnerabilities, verify that they're there, and then exploit them. But again, for this case, let's just take my word for it, and I'll tell you that MS08067 is in fact present on your Windows XP system. So again, let's just pretend no Metasploit, no other exploitation toolkit. We have a couple options. We can, as we have in our lab, set up our own version of our target. In our case, that's going to be Windows XP Service Pack 3. And we can try and build an exploit for it manually. That will require some skill on our part. We will have to figure out how to make a working exploit. That's something we're going to look at a little bit in this class, but it does take a certain amount of time and effort to become a skilled exploit developer. And even with a certain amount of skill, it may take a good deal of time to build a working exploit for a vulnerability, depending on the complexity of the vulnerability, how hard it is to exploit it. So we may be limited on the amount of time. Our time may be better spent working on other vulnerabilities rather than building an exploit from scratch. It really just depends on how much time we have for our tests, as well as how many other things we could be doing. So that may not always be feasible to build it from scratch. Also, depending on what the target is, in this case, just the operating system, you can probably get a hold of that. But it may be some proprietary system, some system that costs a lot of money. It may be more than we're getting paid for the test just to buy the software to hopefully build an exploit for it. So cost may be a factor. It may just be so old it may be impossible to get a working version of it. So you may not always have that opportunity to even build it yourself if you want to. So then we would have another option, which would be to see if we can reuse some code on the internet, which we always have to be a little bit wary of that, because unlike our tools like Metasploit that do vet everything to a large extent, you hopefully won't see anything in Metasploit that ever does anything that it doesn't claim to. I've never seen anything like that. There is a large group of people who do go through all this code and vet it before it is allowed into the framework, but not so with just any old thing out on the internet. If you've ever been on the internet ever, you probably know that people can say whatever they want about anything. Same thing with code. They can put up code that does anything and say it does anything else. There have been some examples of exploits that have been put out online that don't do at all what they say they're going to do. They exploit other systems, like, say, I try and run an exploit against XP here on my Kali machine, and instead of exploiting the XP machine, it instead will attack my Kali system, or it may, in fact, actually exploit the Windows XP machine like it says it will, but then instead of, say, giving us control of that system, it may just destroy it. And certainly our clients wouldn't like that very much. So we do have to be wary, but let's take a look at an example. So I'm going to open up this Iceweasel browser. So that's the world with an Iceweasel on top of it. So this is a derivative of Firefox. So let's just go to one of my favorites. There are others. Security Focus, Packet Storm. There's some other places to find them. Let's go to exploit-db.com. So exploit database, that is the successor to the wildly popular Millworm site. So this is just basically an aggregator of public exploits as well as some white papers, some other things as well. But primarily it's a dumping ground for public exploits. And again, you kind of have to be wary about what's on here. It may or may not be super malicious. So I would always encourage you to make sure you can read everything in it. So let's just do a search for MSO8067 and see what comes up. Seems to be a white paper here about the configure worm, which did use MSO8067. So let's just go to the first one that seems to be an exploit. Alright, so here's an example of public exploit. This is written in Python, my favorite programming language, so I might have a little one up here that I can at least kind of read this and hopefully be able to look up anything I don't understand. Again, I do definitely encourage you to read through the source code of anything that you get offline and make sure you do understand it all. And if there's anything you don't understand or can't understand, then replace it. For example, here we have shellcode and then a lot of hexadecimal bytes after it. I always, when I do live classes, ask anyone in the class if they can figure out exactly what it does. Of course, not cheating and reading the comment here that says bind port TCP port 4444. So it puts us in a kind of philosophical bind here that I said Metasploit doesn't exist, but yet this says it used Metasploit to create the shellcode. But, you know, we could put that there even if it wasn't made by Metasploit, or that if it doesn't make a bind shell. Again, I can't really read that, and again, I always ask, can anybody read that and tell me what it does? I always say, if you can, you have a job, though of course probably they would get much better job offers than anything I could give them if they could in fact tell me what that does, because chances are it's probably encoded as well, so it would be very difficult for a human being to take that lump of hexadecimal and say, I know exactly what it does in human readable format. So this would be something that, if I was working with this exploit, I would want to replace this. We will, when we get into exploit development, see how we can replace this. We will do an example of working with a public exploit like this. So that would be something I would definitely want to take out and replace with shellcode that I trust. And, some stubs here as well, also things I can't read. But primarily it looks like code that I could look up if I don't quite understand it. It seems to be talking SMB. A little bit more weirdness here, but this is, I believe, working with the structure of the SMB packet, so that's something I could look up. Primarily, it looks like the only thing I would really need to change is those shellcode pieces, so I definitely want to make sure they are good. And also, we are working with Windows XP Service Pack 3. This particular exploit works against Windows 2000 and Windows 2003 Service Pack 2, so 2 targets, which is fairly rare among public exploits. They usually just work against 1. But neither of these targets are our target, so this may not work out of the box. We may have to change a few things, like a return address. Again, we'll get more into that when we do exploit development. We'll build something quite like this ourselves. So this may not work for us. We can always, again, build our own lab and try it, just as we have here. If we fail to exploit the system and make it go down in some way, we can always just restart it or restore from snapshot at worst. But we certainly don't want to run this against a client without verifying that it works on their platform and doesn't do anything particularly malicious, only anything that we ask it to do. So we would have to make some changes to this still. It would still take us a bit more time and effort. Hence, enter Metasploit, where someone else has done the heavy lifting for us. So we have a few benefits with Metasploit. One being, there is a lot of oversight with it. There are people who it's their job to look at Metasploit modules that are contributed by the InfoSec community and make sure that they are all above board, do what they say they're going to do before they go into the framework. Additionally, again, here we see only 2 targets with Metasploit. They do a pretty good job of, if the target is vulnerable, it is on the target list. The offsets, return address, etc. for it are in play, so you can just choose the correct payload and, well, correct target, and then a bit ahead of myself there. Also the payloads. Here we're stuck with what claims to be a bind shell, or a shell that listens locally on port 4444. That is the default for Metasploit. So it'll open up, in the case of Windows, command.exe and listen on a port, and we from our attack machine would call back to it, say with netcat or telnet, go to the IP address of XP and 4444, and when we connect, we would be presented with our command shell. But we're limited to this particular payload unless we regenerate the shellcode, which we should. But with Metasploit, we have a wide variety of payloads available to us. Anything that is written for Windows we should be able to use, as long as it fits in the space. Again, we'll get to space for exploits when we do exploit development. But we should have a few more options. We'll see that we do. We have lots of different things we can make it do. So, certainly a step up from this. We will see a couple of cases where we will have to work with public exploits, and again, we'll work with one ourselves during exploit development. But if we have the option, I always like to go for Metasploit. So that is what we will do next. We will actually take a look at using Metasploit to exploit that MSO 8067 and not have to deal with any of the problems we would have here.